Good afternoon, gang. Sorry about that. I just got an email. Okay. So today we're going to do a few things. We're going to be playing with that worksheet that I got you guys last week. Also, if you happen to notice, I'm not sure how likely it is in this online setting that we have an extra individual with us today. My colleague, Professor Steve Grostefan, is here with us today to kind of watch and see how things are going. We've got a few minutes before class formally starts, so I'm going to flip over to the doc cam and kind of get things rolling. This, of course, is MAC1140, section 4. This is a lecture, and today is the 2nd of November, 2020. So you guys have been doing great, kind of building on the material we learned after exam 2, extending our detailed study of functions into exponentials and logarithms. Today, we're going to do more work with exponentials and logarithms. Now you remember last week, of course, we focused primarily on the graphing, right? The kind of basic exponential graphs of the form b to the x, and the basic logarithm graphs that were their inverses, graphs of the form log base b of x. Then we saw how to shift those left, right, up, down, scale them, flip them, do all the fun things. But it was all more or less centered around the graphs. This week, we're going to be focusing more on the algebra. So we're going to talk a lot about the algebraic properties of logarithms and how those connect to the algebra properties of exponents. I'll start by kind of reminding you the rules for exponents. Then we'll see that each of those rules for exponents has a corresponding rules for logarithms. Lily had a good question. When is our next test going to be? So if you take a look at your syllabus, I have a copy of it handy here. You'll see that after we finish log properties, exponential and log equations, and applications, we will be ready for exam 3. Now we're a little bit behind because we slowed down earlier in the semester when we were covering polynomials, so it's certainly not going to be the week of 10:30. That would have been last week. But at the end of this week, we will be done with all of the log equation and application stuff. So by this Wednesday, we will have finished the material for exam 3. And just like the previous 2 exams, that means I'll be releasing the study guide for exam 3 this Wednesday, and the exam itself will be the following Wednesday. So if you want to, let's come back here and mark this on our calendars. That will be the 11th. Logarithms. So I'll leave a little bit of space here. I know this seems like it's happening really fast. But that's just how the semester feels at this time of the year. So exam 3 will be 1 week from this Wednesday. That date is 11/11/2020. So exam 3 will be on the 11th of this month, 9 days from today. Yeah, I do apologize. The dates when I set them in the syllabus are definitely rough dates. And from time to time, we have to slow down and pause. I know some of those theorems back when we were talking about polynomials, they're a little bit challenging to wrap your head around. So it's okay that we took a little bit of extra time there. And it's understandable then that the dates would be a little bit puzzling. So today, come back to what we're focusing on today, exponentials and logs. Particularly, we're worried about the algebra properties. So without any further ado, I kind of want to introduce this material by reminding you of the rules for exponents that hopefully we've encountered in past algebra classes, and then show you the corresponding rule for logarithms. So unless there are any questions about the sort of announcement-y stuff, I'll go ahead and continue. Are there any questions or concerns about the exam 3 date or where we're going bookkeeping wise? Oh goodness, is it? That is going to be a problem then. Let's see. Yeah, I see the 11th is a holiday. Well, I hate to say that we would have to put it off then until the following Monday, but I think it would be unfair to rush it. I'll tell you what I will do, guys. I will go ahead and make a poll. So after we finish with class today, let me come back here to our announcements. So scratch this. Thank you, Gabrielle. That's a good catch. Okay, this is actually a holiday. So watch for a Canvas announcement with a poll. I can't have the exam be on a holiday. Even if you would prefer to take it on that day, because this is a hybrid class, we need to be following the college's calendar. So I cannot force the exam on that day. So what I'll do is I'll construct a poll with 2 or 3 alternate testing dates, which would be normal class dates, and I'll let you guys choose among those. And that means we'll just have to fold the schedule around that a little bit. If we end up going for the later date, be aware that means that there will be some exam 4 material that we'll have to cover before the day of exam 3, just to make everything fit. And if we go for an earlier date, like that Monday, be aware that that means you would have 2 fewer days to study. So the likely dates on that poll will be 11/9, and then whatever the following Monday is. I think that would be 11/16. But watch for the poll in a Canvas announcement. I'll let you guys pick between a couple of different options since we can't do it on this day. And thank you, Gabby, for pointing that out. All right. Make a note here. Okay. So we're going to talk about algebra properties of the logarithm. Like I said earlier, each one of those kind of weird properties of the log come from an algebra property of exponents. So remember, you've got these rules for exponents. And my favorite way to remember the rules for logarithms that we're introducing today is to think of them as being equivalent to a corresponding rule for exponents. So on the left, I'll have rules for exponents, and on the right, I'll put the corresponding rule for logs. One of the things you learned back in high school or in college algebra is that when you multiply like bases, if I have base b raised to some number x, and I multiply that by the same base b raised to another number y, that's the same thing as taking that base b and raising it to the sum of those powers, x plus y. And you can think of this as being a statement about exponential functions, right? B to the x, that's kind of our basic standard exponential function. So it says if you multiply 2 exponential functions on the outside, it's the same as having the one exponential function with the insides added up. The corresponding rule for logarithms is that if you have a log of any base, base b, with a product inside, that's the same as the sum of the logarithms like this. And you can read this left to right or right to left. You can say, I'm going to take a log with a product inside, and I'm going to expand that as a sum of 2 logs. Or maybe somebody hands you a sum of 2 logs. As long as the bases match, you can take that sum of logarithms and rewrite it as a single log where the inside is the product of the insides from the separate logarithms. So this rule that says multiplication inside a log is the same as addition outside the log is really the logarithm version of this rule for exponents. Yeah, of course. Of course, we'll do lots of examples. Let's get the other basic rules here down. So you guys remember that you can multiply like bases. That's the same as adding exponents. What happens if I divide, say, b to the x by b to the y? That's the same as doing what to the exponents? This would be b. Yeah, good, subtraction, perfect. This is the same as b to the x minus y. And the corresponding rule over here in terms of logarithms is that if you have a single log, say base b, and remember b can be any positive number, with a quotient inside, that's the same as the difference of the logarithms. So that's the log base b of x minus the log base b of y. The last kind of rule like this that we're going to get used to today is how you handle sort of consecutive powers. So if I wanted to take b to the x and raise that whole expression to the power of y, this is the same as taking b and raising it to the product of powers x times y. So you raise a power to a power, the result is you multiply the powers. And the corresponding rule for logarithms is that if you have a log of a power, so the base b log of x to the y, everything inside the logarithm here is being raised to the yth power, I can bring that power down in front as a multiple. So these are our three kind of sneaky rules for logarithms, and you have to remember them exactly as they are here. There are some true-false questions in your homework this week that are designed to get at ways that it's possible to misremember these. There are a lot of problems that are crafted to see if you'll do something besides what these permit you to do. I think if you practice with them sufficiently, they will stick in your head nice and clear, but with less than sufficient practice, it's very easy to make little mistakes here. So I'd like everybody to take a second, make sure you have these clear and correct exactly as I've written them here in your notes. These are the three properties that we're introducing today. In addition to these, you certainly should remember or have in your notes the stuff that we had from last week. So did everybody see Lily's question there? Are these the only ones we need to remember? Are there others? There are others, of course. We had the definition of the logarithm. I would say if you're looking to put extra stuff in the same part of your notes, the other things I would have here are that the base b log of b to the x, this is always just x, and b raised to the base b log of x is also just x. This was one of our, remember we had those kind of three different equivalent definitions of the logarithm we played with last week. We said the base b log is the inverse of the base b exponential. That was how we first defined it. Then we wrote down what that meant in terms of algebra, and that was these two statements. That if you compose the base b exponential with the base b logarithm, that always just simplifies to the inside. And then we had that third form, which was equivalent to these, that y is equal to the base b log of x is equivalent to saying that b to the y is equal to x. So if you wanted to put sort of all the algebra facts relating to logarithms in one place, these are them. So far, these are everything that we have. And everything that you'll need to do this week can be thought of as a consequence of these. But really the way to go is to practice with these, right? We want to use them. We want to use them so much that they feel second nature to us. We want this to be like learning a new word in our vocabulary. We play with it in certain contexts until we're comfy, and then once we're comfy, no one can take it away. But if you want to list all of them, these are all of them. All right. Any other sort of questions about bookkeeping stuff or things from last time, or these rules? Are these rules written clearly, correctly? Any questions about what should be written here? Anything hard to read? Okay, so I'm going to tuck these aside for a moment, and I'm going to pull out my logarithm worksheet. All right, this is the worksheet that I sent out to you guys last week, and hopefully we've spent a little bit of time getting to know it. The examples up here are the sort of thing we did together last week. We're evaluating basic logarithm expressions by rewriting them as exponentials. This week, we're going to be playing around with this stuff. These are the rules that we just stated. So we can start by expanding some things. Let's go ahead and do one or two of those. But then I'm going to assign you guys into groups to work on a few problems on your own. So first, I'll grab these three examples and we can play with them. The base b log of xy over z. One of the things that this worksheet has, which frustrates me, and WebAssign has this too, is an absence of parentheses. So that first statement, the base b logarithm of xy over z, I would never write this without putting the argument, the inside of the log, in some parentheses. So this is x, y over z, like this. And if this were a question that I was asking you, I might say expand using log properties. As much as possible. So I'd like you to compare this to those rules and tell me, does anybody see a rule that we could apply to this expression? Yeah, this second rule, right? Certainly inside this logarithm, I have some division going on. And I know that division inside the log is the same as subtraction outside the log. Yeah, and then Leanne correctly identified there's also some multiplication going on inside my log. So first, I would say that the log base b of xy over z is the log base b of xy minus the log base b of z, right? Similar to that subtraction inside, division inside a subtraction outside rule. You have one log with a quotient inside. That's the same as a difference of logs, the log of the top minus the log of the bottom. And the base here is the same as the base here. And then just like Leanne said, this first piece, I can recognize as a log of a product. I've got some multiplication inside here. So ignoring the base b log of z for a minute, just focusing on this, the base b log of x times y is the base b log of x plus the base b log of y. And then this fella, he's just coming along for the ride. Nothing new has happened to him. And there's really no further I could go, right? Each variable has its own log expression. There's no multiplication, division, or powers going on inside the log. So this is expanded as far as possible. This is where we would stop. Is everybody clear on where every piece of this final answer is coming from? Okay. Let's look at a couple more examples. So example 2 asks us to compute or clean up the base 5 log of 5 to the p, right? Yeah, just 5 to the p. And again, I would start by rewriting that with some parentheses, just to make clear what's inside and outside the logarithm, to make it easier for you to see how to use those rules. Which one of the rules can I use here? Yeah, that rule for powers, right? If you have a base b log of anything to any power here, as long as everything inside the logarithm is being raised to that power, you can bring the power down front. So this is p times the base 5 log of 5. And even if this wasn't a 5, I could have done that, right? Even if this was the base 5 log of x to the p, I would have had p times the base 5 log of x. Now there is something special I can do going further. This doesn't follow immediately from one of those 3 rules we just learned. It follows from something that we used last week. Can anybody tell me what is the base 5 log of 5? I think you're on the right track there, Lily, but we need to be a little bit more precise. So it's true that the base b log of b to the x is x, right? We can hang this whole thing on that definition characterization that we had last time. It's true. But I'd like to get to this by using a combination of these things. So we've already said we can bring this power down using our third log property as a multiple. So we get p times the base 5 log of 5. And then Allison claims that the base 5 log of 5 is 1. Why? Because the power to which we need to raise this base in order to get this inside is 1. Remember last week when we'd rewrite a log statement as an exponential statement or an exponential statement as a log statement? So this is really p times 1, which is p. So yeah, Allison, Lily, Danny, you're all correct here. And these are different ways of seeing the same thing. So we know that the base 5 log is the inverse of the base 5 exponential. So this should simplify to p. But then if we think about the algebra properties of the log, pulling the p down, and then the definition of the logarithm here to allow us to compute this as 1, we can get to that same answer just by churning through the algebra. This procedure has some advantages. First, it's a little bit less about memorization. But second, procedures like this can be followed even when the bases don't match beautifully and everything doesn't cancel to 1. If this number wasn't 1, but was some other constant, we could still work with that. Let's do a little bit more of this, just playing around with the rules. And then we're going to talk about how to use these to solve equations. Okay, so I've got here the base 2 log of 8x to the 1/2. Same sort of thing. Let's expand and simplify. The base 2 log of 8x to the 1/2. Sorry, my 8 got a little bit wonky there. All right. So I want to begin with this expression and use some combination of the 3 rules from the last page to expand it out as far as possible into a bunch of pieces all looking nice and simple. Good, good. We can start by bringing that power, the 1/2, down to the front. because everything inside the log is being raised to the 1/2 power. That's the same as 1/2 times the base 2 log of 8x. What can we do now? Yeah, beautiful. I've got multiplication inside my log. So that's the same as having addition outside my log. I'm gonna put some dots here to continue over on this side. That 1/2 is still out front. Now inside, the 8 and the x were both being raised to the 1/2 power. So when I expand this term, they both need to have the 1/2 attached. And for me, I like to do that by opening up a big bracket or a big paren. Say, okay, I'm going to expand this, but I'm going to put it in a big parentheses or a big bracket, so the 1/2 ends up going to everywhere he belongs. So this would be the base 2 log of 8 plus the base 2 log of x. And if we forgot to put some parentheses or brackets here, this wouldn't be correct. So like we said, the 8 and the x were both being raised to the 1/2 power originally, which means both terms that come from them need to get the 1/2 in the expanded form. Is there anything else I can do here? Anything else I can do with this piece? Besides distributing the 1/2? Absolutely, yeah, WebAssign would be perfectly happy with this. But there is one more thing that I would like to see us do. There's one item here which is more complicated than it needs to be. But yeah, WebAssign would be happy with this. What is, yeah, very good. What is the base 2 log of 8? To what power must one raise 2 in order to get 8? Yeah, perfect, 3, right? Very good. 8 is 2 cubed. So the base 2 log of 8 is 3. So this is 1/2 times bracket 3 plus the base 2 log of x. And if you didn't like the brackets here, you could always distribute the 1/2. So that would be 3/2 plus 1/2 times the base log 2 of x. And it's certainly not obvious looking at this that it's equivalent to this. Not something you would just eyeball. So we need to take our time and go one step at a time. Any questions about how we arrived here or arrived at our answer for any of the previous examples? Could be either way. Yes, indeed, Fabrice. You don't need to distribute the 1/2. If you gave me this as your final answer on the test, I would be totally happy with it. WebAssign would also be happy with it. I do like to see the base 2 log of 8 cleaned up to a 3. All right, this looks somewhat intimidating. If I don't know what a logarithm is, I have no idea what that number is, but everybody knows what 3 is. So if you can clean something up real nice like that, let's go ahead and do it. But whether you want to leave it like this or like this, totally up to you. Lily, either one is fine. So if you wanted to, instead of having this as 1/2 times bracket 3 plus log 2x, you can distribute the 1/2 and write it like this. That would be fine also. You could have distributed the 1/2 back at this step if you wanted. Any other questions on these guys? Alrighty then. So what I'm going to do see, how many do we have here all together? We have 15, not including Steve and myself. Oh no, 16, not including Steve and myself. So we have 14 altogether. So let's put you guys into 4 different rooms. We'll assign automatically, except for, I need to pick Steve out. So yeah, let's go here, room 1. I am going to partition you guys into some breakout rooms. And we're going to work on a few different problems from this section. Let's do it like this. And then don't quite split evenly. We'll do it like that. All right, so you're going to get an invitation here to join a breakout room in a second. I'll ask you to go ahead and accept that invitation. All right. And now, Steve, I'm not 100% sure how to bring you around with me. I think I'm going to try to assign you to a room before I jump into it. So let's assign you to room 1. Oh, and we'll come in and visit each of these. 1, join myself. All right, so Allison and Steve, you guys are here, but it looks like Allison, your group mates have not made it in just yet. So I would like to give you a problem to work on, Allison, and then I'm going to come back around to you in just a second, okay? So I'd like you to work this example from the worksheet. If you've taken a look at it before, that's great. And hopefully once your group mates come in, you guys will be able to talk about it together. So I'd like you to work the first exercise here. So I want you to simplify as much as you can. So expand, combine any like terms, do whatever you can do to rewrite this as nicely as possible. Or you could combine and try to cancel. All right, so is the task clear, Allison?
Yeah, you're good, thank you. I have it written down.
Okay, and did you have any questions you wanted to ask about how to get started before I move to the next room?
No, I'm good, thank you.
Okay, great, I'll be back in just a bit. And Steve, I'm gonna try to bring you with me as we move to the next room. I'm into room 2. Move you ahead of me, and then I'll join. Okay, Lily, looks like you've joined, okay, but we're still, again, missing some of your group mates. I'm gonna give you a problem to work on, and then as your group mates come in, you should have 2 more people besides Steve and myself here. I will ask you guys to take a look at the second part of this first exercise. So you wanna simplify this as much as possible. You could do that by combining these into a single log and trying to cancel, or you could expand and try to combine like terms and then recombine, but do whatever you can do to get this as simple and clean as possible, okay? Are there any questions about what it is I'm asking you to do? Looks like Brooks has made it. Just part B. Yeah, you're only responsible for part B here. All right, so I want you to work with Brooks. Make sure you guys come up with a solution you agree. I'm going to come back through in a few minutes to see how you're doing. Steve, I'll go ahead and move you to room 3, and then I'll be in right behind you. All right, okay. Hey guys. So I would like to give you all a problem to work on. It seems like you guys didn't have any trouble getting here. That's great. So turn on my share, we can get you over here. I would like this group to work on part C of exercise 1. So everybody has this packet, or you can write the problem down. You should be able to see it from my screen share now. We want to simplify as much as possible the expression log base 3 of 9x times y squared minus log base 3 of 27xy. And you can do that however you want. You can try to expand and combine like terms. You can try to combine and cancel. Just make sure that you're following those properties, those log algebra rules exactly. And make sure you agree with whatever you come up with. So you guys can work on it, discuss, argue, and then I'll come back in a few minutes and see how everybody is feeling. Any questions about what it is we should be working on or how to get started?
No.
Okay, great. I'll be back through in just a few minutes. We got one more. Hopefully everybody has made it in there all right. I'm going to send you, Steve, over to 4.
It's pretty fun, but
Hey guys. All right, so I have a task for all of you.
all
I
right.
would like for you guys to take a look at part D of problem 1 in this section of that worksheet. So we want to clean up, simplify as much as possible the base 4 log of xy cubed minus the base 4 log of xy. And there's some ambiguity in the notation here that I don't like, so I just want to take a second to make clear. When we say the base 4 log of xy cubed, we mean it like this. Right, so that cube is inside the log, but outside the xy. So the thing you are trying to simplify is that minus the base 4 log of xy. And you can do this however you want. You can try to expand it all and combine like terms. You can try to combine it into a single log and cancel. Whatever attack you feel is most reasonable, you're welcome to use. But then I'm going to come around in a few minutes and see how we're doing. The goal is just to get this as simple as possible, okay? Any questions on how to get started before I head out?
You're good.
You feeling okay? All right, I'll be back in a few minutes to check on you guys. Okay, so I'm going to push us back around to room 1, where it looks like we still haven't had everybody join that should have, but okay, we'll figure it out. Join. Allison, you there?
Yeah.
Okay, it looks like your roommates didn't make it over. I see one who's having a hard time joining, and then the other one looks like they've abandoned ship altogether. So let's take a look at us 3 at this problem you are working on. So you're trying to simplify as much as you could the base 2 log of xy minus the base 2 log of x squared. Do you want to walk me through what you've tried so far? Or do you have a camera so you can show us some of your work? What would you like to do? How's it going?
Yeah, 1 second. Let's see. I don't know if you can see me.
You there? I'll turn off my share here.
I'm just going to hold it up if that's
Yeah.
okay.
Yeah, no, that's great. That's
Okay.
perfect. Yeah, you can just.
I don't know if it's offset or not, but
So I see you've expanded the xy, the log 2 of xy as the base 2 log of x plus the base 2 log of y. And then we brought the power down in the other term. That's good so far. What would we try next? Do you see any terms that could be combined there?
the combine, like, you want us to expand it more?
Well, so what I would like to do is see if there are any terms that can interact with one another. So I like what you have so far. I like this. This looks great. Do you notice any like terms here? Any terms that could interact with one another, could be combined into a single term, not necessarily through the use of log properties, but just the same way that x minus 5x is negative 4x. Anything like that?
Yeah, we just take out log of 2.
So I can't factor out a log of 2, unfortunately, because this is function notation, right? This isn't like log 2 times x. Maybe I'm misunderstanding. What I see here is that these two look pretty similar.
Oh.
Got 1 apple and minus 2 apples. So I could write that as -1
Negative.
log
Okay.
2x, or just negative log 2x, right? Like if this was x and this is minus 2x, then x minus 2x would be negative x, or negative 1x. And this guy here is log 2 of y still.
Yeah, I didn't even see that.
That's okay. This is our first time playing with it, so that's fine. Yeah, these are definitely like terms. And then see if there's anything you can do from here. Maybe see if there's a way you could recombine these into a single log that looks nice and simple. I'm sorry you're working on your own here. I don't know what happened to your group mate,
No, you're fine.
but you're doing great. I'll be back around in just a
No,
second.
I've done this. I've done this stuff before, so it doesn't bother me. I'm
Cool.
just refreshing my brain on it.
Awesome. You're doing good. Okay, Steve, I'm going to move on.
Would you just You'd have to factor out. Can you factor out the negative first and then do it that way? Are we able to factor anything here or no?
There's not really anything that's going to factor nicely. You could force factor a negative, but let me give you a hint. If I was doing this myself, my next step would be to write this as the base 2 log of y minus the base 2 log of x. In the same way that negative x plus y is the same as y minus x, negative log 2 of x plus log 2 of y is log 2 of y minus log 2 of x. And now this is starting to look a lot like one of my properties. So my next line would look something like that. Are you comfy going from here to here?
Yeah. You're just moving it.
Yep. All right then. So I'll be back around to check on you in just a second. Steve, I'm going to move us over to room 2 next.
Is there anything else you want me to do other than this? That's it.
So look at that last line and see if you can apply any of our log properties to that. There is one more thing here that maybe we could do.
Do you want me to condense it?
Yeah, let's try that. Let's try that. All right.
Okay, so then it'd just be log 2x over, or log 2 and then y over x.
That sounds good. Yep. All right, I gotta go. I'll be right back. Hey guys, how's it going over here? Brooks, I saw that you had a question. No? Hey guys, everybody here? Can you guys hear me okay? Lily, I see your question in chat. That's okay, that's okay. Remember, you can hold the space bar to talk, and you can turn your video on and off by clicking the buttons in the bottom left of the Zoom dialog. I see what Lily's typed here. I'll go ahead and transcribe this, and you guys let me know if everybody's on the same page. Okay, I'm gonna turn on my screen share for you guys here. So Lily, am I reading right? This is where you guys have landed? 2 times the quantity, 3 plus log 2x minus log 2y plus 1 plus log 2x plus log 2y? My chat window is misbehaving. Okay. So you guys were working on part B here. Let's see, I'll write this down and then we can I can ask, maybe you can walk me through your steps. So we had the base 2 log of 8x squared over y plus the base 2 log of 2xy. So this first piece becoming this expression and this piece becoming this expression looks good. Since Lily typed this for me, Brooks, could you explain to me a little bit where that bracketed expression comes from? Yeah, this is correct. This is very well done. Yeah, good job. Is there any disagreement about any of these steps or any uncertainty as where any of these things could come from? I do see one little piece that I might argue with, looking at it more closely now. If we pay attention here, let me see, I'll use a different color, to the 8 and the y, are these pieces being squared? So in this first log expression, only the x is being squared. So really only this term should have the 2 out front. Yeah. So while I applaud the use of parentheses everywhere that we may possibly need them, if we wanted to do this real carefully, really we shouldn't have the 2 everywhere here, just here, which negates the need for those brackets. And if we want to see carefully how to make sure each piece gets only what they need, we can take it in steps. And I think one of the common mistakes here is trying to do a little bit too much at once. So first I would take this guy and turn the division inside into subtraction outside. And I would just do that in this step, even if it feels like it's too easy. And here maybe we can go ahead and blow this multiplication apart into addition. And that does still leave us with a bit of work to do here. Yeah, I get it. And it could be a little bit misleading, especially with like poor use of parentheses, as you see in some of the problems they're typed. But if there is an absence of parentheses with a power, like here I just have 8x squared all written side to side and no parentheses, it's safe to assume, following the order of operations, that the power only belongs to the term that you see it directly attached to. So before I brought down the 2, I would take this multiplication inside and rewrite it like this. And all the other terms can come along for the ride. The base 2 log of 2, like you had it, that is 1. And then we have plus the base 2 log of y. Now the maneuver with the base 2 log of 8 being 3, that's correct. You can bring the 2 down here. I would ask you then, is there anything that we could do to combine like terms or simplify after doing that? So the base 2 log of 8 is 3. The base 2 log of x squared is 2 times the base 2 log of x. You've got your minus base 2 log of y plus 1 plus the base 2 log of x plus the base 2 log of y. Do you see any like terms? terms? Any terms here which could be combined? I think my chat window isn't giving me notifications when you guys type. So yeah, okay, there is something here. Brooks, combine the base 2 log of x terms and the base 2 log of y terms. So either way is correct, yes. Yes, here I have 2 copies of the base 2 log of x plus 1 copy of the base 2 log of x. So this and this can be combined. And then if we're looking at the y's, I've got 1 copy of the base 2 log of y, and it's negative. And here I've got 1 copy of the base 2 log of y, and that's positive. And if we're really being fun about it, I have a constant here and a constant here that can be combined as well. Yeah, good. Okay. So let's combine these like terms and see what we get, all right? Of the 3 and the 1, the positive 2 log base 2 of x, positive 1 log base 2 of x, and then negative base 2 log of y, positive base 2 log of y. I will leave it to you guys from here. I'm going to run through the other rooms really quick to see how everybody else is doing, and then we're going to come back together. So I'll have about 4 or 5 more minutes, okay? Steve, I'm going to push you to room 3, and I will be right behind you. Oh, where did they go? Fabrice and Gabrielle, ooh, both jumped out of the room. Okay, maybe they're satisfied with their problem. Let's jump to room 4, and then if they're doing okay, we'll collapse everything back together. Room 4. Steve. Okay, guys, how's it going? Is there anything that we're stuck on? We got it all sorted out? How are we feeling?
I think
I got an answer.
I feel pretty good.
Feel pretty good? All right, you want to walk me through what we've done so far?
Should I go? I'll go. Okay, so for the one that you gave us, it was log 4 3 xy to the third minus log 4 xy. So then the 3 exponent, I put it to the front, like I did the bracket thing.
Good.
Right? I put the 3 at the front. And then expanded the log 4 xy. So then that became log 4x plus log 4y.
So let me make sure I'm following you exactly as you have it written. You brought this 3 down. So we have then the log base 4 of x times y like this.
Yes.
And then you said you expanded the log of x times y here. So what exactly did you end up with here?
Log 4x plus log 4y.
Okay. I have a question to everybody in the room. Is this, as it's written now, correct?
It still needs to be expanded, the 3 log 4 xy.
True. So we could go further, but is this erroneous in any way? Is there anything wrong with what's written here?
I don't think so.
So let me, suppose I, how do we say this? Suppose I had something like this, and I told you that z is equal to a plus b. Would it be true then to say that this expression is the same as x minus a plus b? Or should I write x minus parentheses a plus b like this?
Parentheses.
Right, because the z here is sort of a single chunk, and I'm subtracting all of this chunk from x. In the same manner, this apparatus, the base 4 log of xy, is a single chunk, and it's all being subtracted. So here, I want to put some big parentheses like that. It's a little bit subtle, But if you think of it, each of these terms is a piece of this thing. And this whole thing was being subtracted. So each of these terms need to be subtracted. So it's not there's an error made, but we want to be real careful.
Towards the front of the equation, we sort of did something like that because we bracketed off the 3 log 4 xy. So it was in brackets there, and then that was subtracting from it. So that's why.
So let's see. So we'd have this, right?
Yeah.
Yes.
Our first bit. And in the same way that this 3 needs to be distributed to everybody, the negative here needs to be distributed to everybody. So you can think of this as being the same sort of thing, only in place of this 3, we have this negative. So if I then distribute this negative, I'll have minus log 4x minus log 4y. And then if we want to, we can distribute the 3 and combine all of our like terms. So this would be 3 times the base 4 log of x plus 3 times the base 4 log of y minus the base 4 log of x minus the base 4 log of y. And now do you see anything that could be combined? Do you see any pieces that can play together or interact with one another?
Yes. The final answer would have been like 2 log 4 of x and then plus 2 log 4 of y.
Excellent. Yeah, these guys can play together because they're both log 4 of x, and these guys can play together because they're also like terms, both log 4 of y. All right, sounds like you guys got this under control. Any questions about where any of these pieces came from or where they're going?
Sir?
No, sir.
All right, sweet. Then I'm going to bring us all back together into one room. We'll go over the remaining problems and then we'll move on from there. Okay, so the rooms, close all rooms. All right, thank you. Sorry, I forgot my mic muted coming out of there. So our first group was trying to simplify this expression as much as possible. And there's a few different ways to attack this. We can expand this, combine our like terms. So that would look like the base 2 log of x plus the base 2 log of y. And then here I can bring the 2 down, so that would be minus 2 base 2 log of x. This and this being like terms, we can combine them. One of these things minus 2 of these things is negative 1 of these things. In other words, we have the base 2 log of y, this middle term hanging out. And then negative 2 of these plus 1 of these, that's negative 1 of those. So this would be a valid answer. If you wanted to, you could combine these back into a single expression as the base 2 log of y over x. There is another way to get there. If I wanted to, right from the start, rather than expanding and combining like terms, I could combine and say the original expression is equal to one logarithm base 2, because here I've got a log of one thing minus a log of another thing, and the bases are the same. XY divided by x squared. So I'm using that rule that division inside is the same as subtraction outside, but I'm using it going in the other direction, saying that this difference of logarithms is the same as this log of a quotient. And now within the logarithm, I have xy over x squared. I can cancel one of those x's, right? This is x times y over x times x. So that's the same as the base 2 log of y over x, canceling this x into that square. And you see we get the same answer. It's a matter of taste which technique you find easier to do. As long as you arrive at this same place, it's all good. The second group was working on part B, where we've got the base 2 log of 8x squared over y and we want to add to that the base 2 log of 2xy. Again, we could expand everything as much as possible, combine all the like terms, and then reassemble. And that's what I think this group ended up doing. But another way to attack this is to begin by putting these two different log statements into a single log statement. So an alternate approach here would be to write this as the base 2 log of this inside times this inside. That's 8x squared over y times 2xy. Now, this y and this y can cancel. I have 8x squared times 2x. So inside my logarithm here, 8 times 2 is 16. X times x is x cubed. And now if you wanted to, we could expand this as the base 2 log of 16 plus the base 2 log of x cubed. 16 is 2 to the 4. So 2 raised to what power is 16? 2 raised to the 4 is 16. And the base 2 log of x cubed, this power can come down. So I get 3 times the base 2 log of x, which is the same answer that this group got by blowing everything apart and combining like terms, then recombining whatever bits they could. And either one is totally fine. If you would rather start by writing this as a difference and then expanding the 8x squared as a sum, expanding this as a sum, combining and simplifying all of those pieces, you'll still get to the same answer. I just wanted to show that this could be done another way by combining them at the start. Our next group, let's see, was asked to work with part D here. I think we skipped over part C. A non-responsive group there. So we had the base 4 log of xy cubed minus the base 4 log of xy. And definitely we could bring the 3 down and then work with these two on their own. Or we could combine them into a single log. where the inside would be xy cubed over xy. It's convenient to do it like this because then the xy and the xy cubed can interact with each other as a ratio. If you brought the 3 down, they would interact as a difference. But here I've got something cubed divided by that same thing. So this would be the base 4 log of xy squared. And depending on whether you want this as expanded as possible or as small as possible, you could leave it like this, or you could bring the 2 down and then have the base 4 log of xy, and then expand that base 4 log of xy as the base 4 log of x plus the base 4 log of y. So my goal here was just to get you guys a little bit of practice playing with these rules, hopefully becoming a little bit fluid, recognizing common pitfalls, and little ways you can sort of shorten the work, little ways you can become accustomed to what's going on. Last Wednesday, when we finished class, we talked about the utility of logarithms. We mentioned that there are some equations that from the graphs we can justify must have solutions, but the solutions aren't easy to read off from the graphs, and they weren't necessarily easy to read off in terms of the exponential algebra either. There was a good question asked in chat, how can we say what is most simplified? I think this is one of those places where there's a little bit of subjectivity to it. So on an exam, and certainly in the homework questions, I'll be very explicit about what I mean by most simplified. Either write as a single logarithm or write fully expanded so that there are no powers or ratios or products inside of a logarithm. So the term simplify has a little bit of subjectivity, but in any of these problems, what you consider most simple might vary from what somebody else considers most simple. When I look at these, what is most simple to me is when I can see each piece on its own, and it's very, very clear to me what the domain is. So remember, we talked about domains of logarithm functions. From here, it's not entirely clear to me what values of x and y I'm allowed to plug in, nor is the graph or any of those things clear to me. But from here, it's very clear to me that, oh, okay, if this is to be defined, x must be positive. If this is to be defined, y must be positive. And in the context of problems that I'll ask you guys to solve on tests and in homework, I'll always be really clear about what I mean by most simple, either fully expanded or written as a single logarithm. That's a good question. So getting back to where we left off last time, we said there are some solutions, there are some equations, the solutions to which are not entirely obvious, but we know they exist. I think the example we used was the equation 2 to the x equals 3. If we look at the graph of 2 to the x, we know when x is 1, we're up here at 2. We know we have this y-intercept of 0, 1. And when x is equal to 2, we're all the way up here at 4. Because this graph is nice and continuous, somewhere he hits the y value 3. So somewhere in between 1 and 2, there is a solution to the equation 2 to the x equals 3. The graph here is y equals 2 to the x. All of the work we've done with logarithms is leading us to a place where we can, purely in terms of algebra, without any guessing or any numerical work or any calculators, come up with solutions to equations that look like this. In answer to Lily's question, yes. Yes, that is okay. You can bring the 3 down there. So the new operation that we're going to be working with, there's actually 2 of them. The first one I'd like to introduce here is take logs, or put both sides into a logarithm. This is an operation like square both sides or take the square root of both sides. It's an operation you can do to both sides of an equation. And because of the algebraic properties of logarithms, it will have the effect of bringing this variable down out of the power into a place where you can manipulate it directly. So let me show you what I mean. If I start with the equation 2 to the x equals 3, I can take logs on both sides. In this case, I'll take base 2 logs. Which looks like this. I'll have log base 2 of 2 to the x equals log base 2 of 3. Now, following the algebra properties, this x can come down here. And I'll have x times the base 2 log of 2 is equal to the base 2 log of 3. The base 2 log of 2 is 1. So this is the same as saying x times 1 is the base 2 log of 3, or just x equals base 2 log of 3. And the astute among you may have noticed that there's no dependency on the base of the logarithm. If I'd taken any other base logarithm, I could have still pulled this power down. It's just that this piece would not have necessarily simplified to 1. So another way to solve this equation, let's look at a different example. So another way to solve this equation would have been to take the natural log, or the base 10 log, or the base 5 log. And I could have followed a very similar procedure, except when I got to this step, rather than having a 1 here, I'd have some other constant that I need to juggle around. So let's look at this expression. Maybe 3 to the x minus 1 is equal to 40. Again, I want to solve the equation for x. I'm going to use a logarithm. And while I could use the base 3 logarithm, kind of following the pattern of the previous problem, I claim that in the previous problem, we could have used whatever log we wanted. Now, on your calculators and in other mathematics hardware, you'll usually find just 2 options for logarithms, the natural log and the common log, those special logs we talked about last time. If I take the natural log on both sides here, so here I'll take the natural log on both sides, meaning I put both of the sides inside the natural log. The left-hand side will still simplify nicely, just not quite as nicely as it would have if I used a base 3 log. The power here is this stuff, the x minus 1. So he can come down front, and I'll get x minus 1. I like to put it in parentheses to remind myself that that is an individual chunk. You should too. times the natural log of 3 is equal to the natural log of 40. And while I don't know what the natural log of 3 is off the top of my head, nor do I know what the natural log of 40 is, I know that they're both just numbers. So I can move them around and treat them as I treat any other constant in an equation. In particular, if I want to solve for x here, I can begin by dividing both sides by the natural log of 3. That will get me to an x minus 1 on the left. So I divide both sides by ln 3, and I get on the left x minus 1, on the right ln 40 over ln 3. And now finally, if I add 1 to both sides, I'll get x equals ln 40 over ln 3 plus 1. So this would be the solution to that equation. It's not very easy to take a guess at how large this is. Is this bigger or smaller than 1? Bigger or smaller than 5? Bigger or smaller than 10? None of those are super obvious in this form because we don't have a great intuition for the size of ln 40 or for the size of ln 3. We call this the exact form in terms of logarithms. And there will be plenty of questions in your homework and on the test where I ask you for the exact solution in terms of logarithms. But if we wanted to approximate this, we could feed this to our calculator and it would give us a decimal. We're short on time. I'd like to do one more example with you guys where we're solving an exponential equation using logarithms. So I'll ask you to bear with me for just 2 or 3 more minutes. We might go over by just a minute here. So the other way we take this stuff, evaluate these log equations. Well, maybe this is an okay place to do one more. Here, we'll do it like this. Let's solve a natural exponential equation. So next time we're going to talk about how to solve logarithm equations, and we'll talk about that other operation. But for now, if I want to get my variable down out of this exponent, just like the previous 2 examples, we need to take a logarithm. I would begin by taking the natural log of both sides. And then on the left-hand side, I can again bring this power down. So I'd have negative 2x times the natural log of e is equal to the natural log of 5. What is the natural log of e? Remember from last time? Yeah, good, Allison. The natural log is the base e logarithm. So the natural log of e is the power to which one must raise e in order to get e. So this is 1. Just like the base 5 log of 5 or the base 2 log of 2 is 1. So we get negative 2x is equal to the natural log of 5. And now we can divide both sides by negative 2. And we get x equals negative ln 5 over 2. So solving exponential equations always goes this way, right? You want to isolate your exponential term, then take logs. Next time, I'm going to show you some more complicated examples of exponential equations where you're not right away given an exponential expression equals a constant. And we're also going to talk about sort of the other direction in this process, where instead of having a variable trapped inside an exponent, it's trapped inside of a logarithm. and we'll have another fresh verb. So like take logs is our fresh verb for today. We'll learn how to undo a logarithm by exponentiating. I'd caution you to think of this as cancellation. So I've seen a lot of people, and I'm glad you mentioned that, Leanna, say that the natural log and e cancel. It's not necessarily wrong to say that, but you should be mindful that it's not the same thing as cancellation in like a fraction where you factor the top and the bottom and there's a cancel factor. Here, they're undoing each other in the way that functions undo their inverses. So the ln and the e to some stuff cancel in the same way that x squared and the square root function cancel. Which is not quite the same way as like algebraic cancellation that we're used to. If that's how you learned it and that's how you're comfortable with it, that's okay. But make sure you can also justify those steps through a procedure like this, where you apply one of those log properties and then you make a statement about the value of the piece that's left over here. Okay, great, I'm glad. Any other questions here before I let you guys go for the afternoon? All right, I do have my normal office hour from 3:30 to 4:30 today, and then I will see you guys either there or in our class on Wednesday, also a normal office hour Tuesday. So yep, if there's anything else that you guys want to talk to me about, please come see me in an office hour, shoot me a Canvas message. As always, there is a homework up for you to work on if you need extensions. I did go through and clear all the WebAssign extensions that were in this morning. If you've submitted a new extension since then, I will be taking a look at those in the next couple of hours. Otherwise, I wish you guys the best. And if you want to solve problems or talk about anything in particular, just come see me in office hours. Okay. All right. Take care, everybody. Have a lovely rest of your afternoon. And I will see you next time or in office hours.